All right, so I've got most of the spoil board cut for the second time now. This time with the Y gantry squared up to the machine, so that works much better. Um, I've got a series of cuts just in case you haven't seen the other videos. What I've done is kind of recreated the match fit system, or it's a spoil board. All right, so I'm still waiting on some magnets for my dust boot, but I have the rest of the spoil board carved here, as you can see. So these are the essentially access holes for the match fit bit, and then the relief grooves that were cut with a 1/4 inch end mill. So I'm going to use the match fit dovetail bit at full depth to basically now come back, and if everything works out well, cut the remaining slots. So that's what I'm going to set up for. I am excited to try this spoil board. I've got a couple 3D printed pegs. I've got to reprint them a little bit smaller. The tolerances are a little high, but the theory being that these will act as essentially index points or dogs to go in the hole. But I do need to reprint them a little bit smaller. So I'll get on that while this is cutting. But let's get that bit swapped out and get the dovetail bit in, and we'll see how this goes. All right. All right, so I wanted to give you a little bit of an update. Testing 1, 2, 3. Testing. Test 1, 2, 3. Test 1, 2, 3. All right, so I just wanted to give a little update as to kind of where I'm at with my build. I have my new spoil board design mostly ready. Took 2 different attempts to cut it, not because there was anything actually wrong with the file, but because I forgot to square the Y gantry after making some changes after I did a couple of the cuts. I had done the whole layout. No, sorry, I had done the little entry points for the match fit system. And then I moved the machine and didn't re-square the gantry after I moved it. And then started to cut the circles, and they were all off kilter because the Y axis was skewed probably about an inch and a half, maybe. So they were pretty off. So I recut everything once the machine was in its final position, so that was great. I've got some brackets being printed so that I can secure the frame to the table itself. So just going to print some brackets, and I was looking at some metal ones. If the printed ones don't hold up, they're pretty substantial, but I'm just planning to attach it to the 2020 base extrusion and then put a couple screws into the top of the workbench, and that should hold the machine, which should in turn reduce some of the vibration and make things more rigid. So a few things about the spoil board. I'm going to release or publish, I don't know, the file on Easel. So this was all printed. This was all designed and done in Easel. The grid I created in Fusion 360, but I'm really slow at the cam in Fusion 360. So I took and exported the design file once I had all the dimensions as a DXF, imported it into Easel, and then created the actual cuts. So the project itself, when you see it, will actually have 4 different cuts. So there's a separate cut for the ovals here for the match fit piece. There's a separate cut for the circles. There's a relief groove that's done with a 1/4 inch bit here, and then you use the match fit or a dovetail bit. This is the one I used, was the 1/4 inch match fit bit. Let's see if I get that on camera. There we go. So that's the match fit bit I used, and that's a full depth cut to make those dovetails. So you do want to make sure that relief groove gets cut first, because if you have to do a full depth cut with this, and if you tried to do it without those grooves, you might have some trouble, depending on your machine, I guess. But yeah, that's why the separate cuts, so you can do as much or as little as you want. I previously, on my other machine, I had T-track and MDF slats. Because of the way the frame sits, I wasn't sure about putting down, a 3/4 inch piece and then putting T-track and Spoilboard on top of that, if I would lose more Z height or clearance than I wanted. So I did just go with a 3/4 inch. It's a little bit thicker. It's actually 19 mil MDF product. So this is an MDF product with just a a melamine top on it. It's quite nice. The reason I ended up with it was there's a company in town that I was able to get some from. So it was a easy, cheap way to do it. Now, one thing you'll notice is it's all white. That's because I haven't surfaced it. I do have a surfacing bit. I do plan on surfacing it. I did check it. It's quite good. Depth-wise, there wasn't too many low spots. It isn't surfaced. I am aware of that. I will need to take care of that. Obviously, you'd want to surface it before doing the cuts, because that would change the depth of the dovetails. And if you surface it after, you might have issues with your dovetails depending on how much you had to take off. But for now, I just wanted to get kind of a project running, make a cut, see how things are kind of working now that I have the Spoilboard all cut. So just to kind of go over what I have. So here is the match fit pieces. So this lighter green piece is the actual match fit hardware. So this fits into the dovetailed track. Move this. So this fits into here and then can slide along in any of these positions, or you can put it in here and slide it along there. So the idea is you've got lots of clamping options, which is kind of fun. The other thing that I found on printables is just these little dovetail adapters for T-bolts. So if you've already got a bunch of T-track bolts, you can use those as well, just with this printed insert. They do work just with the metal bit, but you do run the risk of wrecking that dovetail. So this just kind of fills that out and makes a dovetail component that slides in the track and sits nice. These tops aren't 3D printed. I ordered a set of T-bolts, and they came, the set I ordered came with these tops, so that's where those came from. So with that as well, you've got, move it over just a little bit here, but in this corner, I've got these two smaller or closer together holes, and then we've got the grid on the outside. So the idea being that I can take these little 3D printed dogs. These are just 1/2 inch holes, or 12.7 millimeter holes. So really most 1/2 inch things, as long as they are 1/2 inch, should fit in there. But I'll release those files with the Spoilboard files as well. But the idea being that I can take and put some of these pins in here. And similar idea to lots of Spoilboards. I mean, this isn't anything unique or new, but now I've got a solid reference point here. I will figure out this datum point. And then from there, I now have a repeatable reference point. Every time I put in square stock, I've got a reference point that I can utilize. So now I can move my clamps using the match fit system into place, and I've got lots of different options where they can be. I can get the clamps out in either direction. So if I have stock here, obviously I can take this clamp, and we've got a few too many things in the way here, but get a few of these things out of here. And move this over. So I can pull this clamp out, and I could say put it in here, run it over and up, and get some clamping pressure on this side now. So now my piece is nice and locked in there. It's set in this reference point. I'm just going to move this clamp in a little bit. And I could add another clamp if I wanted. If there was a reason, I did print these taller, they're just 1/2-inch index pins. So again, they just go in there, and you can butt stock up against them. The other thing that I don't have, but I was interested to try, is doing something like this and then putting a wedge piece here. So I could try that as well. So I may end up trying that. And the other thing I got printed was I finished off the dust boot. So this is the Bee CNC version 5 dust boot from Thingiverse. And it just has a couple small modifications from a couple people on Thingiverse. And I printed this one. I did end up purchasing the maker file for the V8, which is a Z independent. I'm going to build a bracketing system to have a Z independent dust shoe that goes out the back. So rather than the hose coming way up top, it'll just come out the back and should work well. But this for now will get me started until I have time to design that. So it just clips in place and it's easy to pull off should I need to. Okay, so I've got a small test file. We've got our stock secured. Now I haven't actually figured out the reference point just yet. So I do need to actually figure out what this point is. But for right now, and the file I wanted to run, it's not so important. So I think we should just run it. So I've got a quick, hopefully quick anyway, test file I made in Lightburn. Actually, I did the design in Lightburn, exported the SVG, and brought it into Easel. So if anybody is interested or has some questions, I am happy to do a little bit of a video on that. Definitely not very good at the visual design part, but the computer part and knowing what programs to use where, I do have that more sorted anyway. So I'm going to bring the machine forward here. Actually, you know what? I'm going to home it just because I haven't in a little while. And I've mucked around with it, so. Okay. Okay, so I think I have it pretty close, so we'll just see where I'm at. The idea being that then you would home the machine and then you would set your one of your workspaces, so like G55 or something like that, to be this point. I also plan to get a little vise, and then I would set that up as a different workspace. Okay, so let's just bring this down and see how close we are. and see if we need to reset the Z here. Yeah, so I'm not quite there. Again, probably close enough for this job, but while I'm here, I might as well set this. Okay, so let's set 0 and 0, normal. Okay, so one other thing, just quickly that I did that I wanted to show you is what I did with my Z probe. So my spindle, and you could do this with a router, it would just take a little bit of figuring, but with my spindle, it has the 3 wires for power and then a grounding cable. So it's a 4-wire conductor, and that runs back, take you out of here, that runs back over to here. So the spindle is then grounded to this ground. I'll pull this off. That ground terminal is both the power, so this goes to the 110, and this green cable runs back to the spindle. So that's a grounding point on the VFD. So what I did is I took the alligator clip from the probe, the touch probe, and I just clipped it onto that grounding screw. Now I took it off and now I can't get it back on, but basically it just needs to make an electrical connection. Now there's a few different ways I could do this. This is just my temporary kind of see if it worked, and it does work very well. So the advantage of this is I now have the alligator clip connected there. I then take my touch probe here, get back over here. So now I can put this under. I don't have anything connected to the bit, but because the spindle is grounded in G sender, when I touch probe, it's going to say, okay, I need you to touch the bit to the plate. So again, there's nothing connecting this other than the ground wire and the spindle, but we'll touch that off. Oops. I'll do that again. There we go. So you can see that when I touch the plate to the bit, we have a connection. We're good to go. So because the spindle is already grounded, I'm good that way. I don't need to worry about the alligator clip because I always forget the alligator clip. I don't know if you're like me, but yes, the alligator clip is kind of terrible that way. Okay, back to the mount here. Okay, so I'm going to probe the Z height. And I've just got an 1/8 inch flat end mill in there right now. Okay, so we have Z sorted. I'm gonna move this out of the way. We've zeroed X and Y. And if you didn't see earlier, I'm just running this little Bee. So I just the Bulkman or Ultimate Bee CNC logo. I just took and got a picture of it on the side of the machine and put it into Lightburn and traced the image and cleaned it up a bit, and then turned it into a file to cut. I just thought it would be a fun, good test file in this case. So I'm going to move some of the crap off of the spoilboard here. Make sure I don't run into anything. This is the problem with having it as your work area. So there's always stuff to clean up. Okay. Sure the pump is on. And I'm going to put the dust boot on. So I'm going to drop you down just a little bit here. Hopefully you can see a little bit better. You zoom in a little bit. Down a little bit more. Going up a little bit. There we go. Okay, so we're going to bring the Z-axis up and put the dust boot on. There's a better way to do that, but whatever. Dust boot on. See if this makes much of a difference. And we're going to cut. All right, vacuum. Okay. So we'll just move you back up. So that actually cut quite well. I let it run. It was kind of a funny one. I had increased the percent, the speed percentage in GSender. So it was actually running at 180%. So some of those cuts, now they're not very big, but they were running at 3,000 millimeters per minute, which is pretty good. The cutter is a pretty inexpensive, like 5-pack something generic from Amazon, and it's just a 1/8 inch flat head, flat bottom cutter. And yeah, so it did produce some fuzzies, nothing that, you know, a couple quick passes with some sandpaper wouldn't resolve. And I definitely have a better compression bit. I just thought that for this test I would run it with a cheap bit and see how it went. So for my first, you know, cut project that wasn't the spoil board, I think that went quite well. Overall, the machine is fantastic. I'm coming from an MP CNC, so this is quite an upgrade as far as just the power, depth of cut. These cuts were made at 2 millimeters deep each pass, so that's pretty cool. I did have to add a new clip. I don't know if that was seen on the video, or new clamp. It did shift a little bit on me while it was doing some of those initial cuts, and I think that was a combination of the speed that it was running, as well as this material has a melamine back on it as well, so that melamine on melamine probably creates a pretty slick surface, and it was moving just a little bit, so I did add an additional clamp back here. So yeah, overall, I do plan to do kind of a larger, you know, thoughts video on the Ultimate Bee, but I definitely want to get a few projects done. And yeah, I've got some bottle cap openers that I want to get cut for some friends, and a few projects that I want to get working on. But for now, I think that's where I'm going to leave it. So I am happy. Spoil board's down, successful test cut. The dust boot worked awesome. I just have it hooked up to a small household vacuum right now, and a makeshift separator. So it definitely could provide more suction, but it was pretty good, and it stayed reasonably clean, at least the work surface, which is what I was hoping for. So yeah, very happy with that. Thanks, guys.
Cruising down the highway, windows down low. Sunset paints the sky in a fiery glow. Mountains rise up, touching clouds above. Valleys below, filled with whispers of love. On this road, every seed's a delight. From sunrise to starlight, day to night. Nature's canvas unfolding so grand. In this journey, we're living